Hello, and welcome to this training on Retrieval-Augmented Generation, or RAG. In this training, you will discover how RAG works, which issues it solves, and how you can use RAG in network operations. Generative Pre-trained Transformers, or GPTs, are exceptionally good at understanding and generating human-like texts, making them useful in almost any profession. However, GPT systems predict the most probable answer, which might be inaccurate or even false. This phenomenon is called hallucination. The problem of hallucination is worse when you ask a GPT model about something that was not part of its initial training data. For example, imagine asking a language model trained on medical data how to effectively use access control lists, or ACLs, in your network. A prompt saying, "How to effectively use ACLs," might be misunderstood by the GPT. Instead of discussing firewalls or data filters, it might explain that the key to effectively using your ACLs, which are also ligaments in your knees, is a good warm-up and stretching routine. So, how can you prevent hallucination? The most obvious method is to train a GPT model from scratch using a dataset that contains all the required information. However, training requires a lot of expertise, time, and compute resources, making it a rather expensive solution. You can also take a GPT model that was already trained on various data and train it on additional data that covers your use case. This method is known as fine-tuning. Although it is less demanding than training, it still requires some expertise, time, and compute resources, resulting in a considerable cost. RAG, on the other hand, uses a general pre-trained model, just like in fine-tuning, but takes advantage of external data sources to gather relevant information. Also, it does not change the GPT model in any way, requiring less expertise, time, and compute resources compared to the other methods. RAG is the most cost-effective way of adding data to a GPT model. The central part of RAG is a knowledge base, which is a large repository of information that the system can draw from. This knowledge base can be created from various sources, such as texts or Word files, PDF documents, web pages, or live feeds. The text from the source files is first extracted and converted into arrays of numbers, called vectors, and stored in a vector database that is optimized for search and retrieval. When you enter a prompt into a RAG system, it finds the text relevant to the prompt in the database and extracts it as context. Both the context and the prompt are sent to the underlying GPT for processing. The produced answer is accurate and correct as it is based on factual data provided by the context. You are probably wondering how to build and use such a system. Splitting the text, converting it into vectors, and retrieving relevant context are complicated tasks and demand programming expertise. Luckily, there are a few publicly available tools that provide you with vector storage that can help you. To use such tools, you simply upload your documents and start referring to them in your prompts. For example, you could capture your entire configuration with the show running config command. You could also add the information of how your devices are connected using show CDP neighbors. Once you store all the information into text files or format supported by your RAG application, you are able to chat with your network. For instance, you could ask it if a PC can reach a specific server based on their IP addresses, or maybe consult the system if the configuration you intend to implement can cause problems. Better yet, you might want to add additional telemetry data to your RAG system to aid you with troubleshooting. In this training, you have discovered how RAG works, which issues it solves, and how you can use RAG in network operations. Now you can use this knowledge to optimize your day-to-day networking tasks. Thanks for watching.